Okay, now let us see the next question. Test the analyticity of the following functions. Here f of z is equal to sin z. Second question is f of z is equal to z bar n. So here first let us start with the first question. F of z is equal to sin z. So sin z means we can write z as x plus iy. And then here since we are having trigonometric function sine, so we can consider it as sine of a plus b. So already we know that the formula for sine of a plus b. Sine of a plus b is nothing but sine a cos b plus cos a sine b. So here we can use that. So that sine a cos b, that is cos iy, plus cos a sine b. Right? But here we should notice one thing, that cos of iy we are having. But there is one formula that cos iy can be written as cos hy, that is h represents for hyperbolic function. Similarly, in case of sine also, we can write sine iy can be written as I into sine hy. So since here we are having I, we can write it like this: sine x cos hy plus I into cos x sine hy. So if we notice, this is of the form u plus I into v. That is, sin x cos hy is considered as real part and cos x sin hy is considered as imaginary part. So that what we can do here is, we can consider u as sin x cos hy and then v is equal to cos x sin hy. So now as usual we want to find out the first order partial derivative, dou u by dou x and dou u by dou y. Similarly here dou v by dou x and dou v by dou y. So let us see the first order partial derivative. So dou u by dou x is differentiation of sin x is cos x into cos hy. Similarly, here dou v by dou x is, this is minus sin x because differentiation of cos is minus sin and then sin hy. Similarly, dou u by dou y is, we have to differentiate cos hy with respect to y. So under hyperbolic function, differentiation of cos is sin and differentiation of sin is cos. No negative sign will come. So that here we can write it directly sin x and then here it should be sin hy. Similarly, here dou v by dou y should be cos x into cos hy. So minus won't come. Okay. So now we have to check for Cauchy Riemann equation. So dou u by dou x should be equal to dou v by dou y. So if we notice this, this is cos x cos hy. Here again cos x cos hy. So dou u by dou x is equal to dou v by dou y. And similarly, dou u by dou y should be equal to minus dou v by dou x. So here sin x sin hy. Similarly, here sin x sin hy, but minus is here. So this and this also same. Okay. So that what we can conclude here is dou u by dou x is equal to dou v by dou y and dou u by dou y is equal to minus dou v by dou x. And moreover, all the first order partial derivatives are continuous and hence we can conclude that the function here is sin z is an analytic function. Right? So next is we have to move on to the second question. What is the second question is, here we have considered f of z is equal to z bar n. So if we have noticed here z bar n, here as usual we can't able to write z bar n as x plus iy whole power n. Because since it is x plus iy whole power n, we have to use binomial expansion here. While doing like that, it goes infinite number of terms it will contain. More number of terms. Okay, since it is a binomial expansion, it will be containing more number of terms in which it is very difficult to split real and imaginary part. Right? So in this case, here we have to use polar form of complex variable. So instead of taking x plus iy, we have to consider r e power I theta whole power n. So which means that here we can write r power n into here I into e power I into n theta. So now it is easy to split real and imaginary part. So that here what we can do here is, instead of taking z as x plus iy, we have to take r into e power I theta. So here r into e to the power I theta, so that we can, since whole power n, we can write it like this. So this is equal to r power n into, already we know that Euler formula e power I theta is equal to cos theta plus I sin theta. So since it is whole power n, here it becomes cos n theta plus I into sin n theta, right? So now we can multiply this r power n, so that we get equation like this, which means that this is real part and this is imaginary part. It is of the form u plus iv. That is, here f of z is considered as u plus iv, which means that u is what? U is r power n into cos n theta, and v is equal to r power n into sin n theta. So since we are having equation in terms of r and theta, we have to use polar form of Cauchy Riemann equation. Since polar form of Cauchy Riemann equation means, here the first order partial derivative should be with respect to r and theta. Clear? So here again with respect to r and with respect to theta. So what is partial derivative of u with respect to r? Here we are having r power n. So this can be written as n into r power n minus 1 while differentiating it into cos n theta. While differentiating with respect to theta, r power n remains the same, but differentiation of cos n theta is what? Minus n sin n theta, because differentiation of cos is minus sin. Moreover, n theta we are having, so we have to multiply by n. Similarly, here dou v by dou r can be written as n into r power n minus 1 into sin n theta. Same thing with respect to theta, it becomes r power n, and here differentiation of sin is plus cos. So it becomes simply n into cos n theta. Clear? So now we have to check for Cauchy Riemann equation in polar form. So first let us remember or recall the Cauchy Riemann equation in polar form. What is that? Is ur is equal to 1 by r into v theta, and another equation is vr should be equal to minus 1 by r into u theta. So this is a usual notation. Ur is nothing but dou u by dou r. So we have to check here. What is dou u by dou r? Dou u by dou r is n into r power n minus 1 cos n theta, which is equal to 1 by r into what is v theta? V theta is dou v by dou theta. Here we can write r power n into cos n theta. Clear? And then again vr. Vr is what? Dou v by dou r. So n into r power n minus 1 sin n theta is equal to 1 by r into, sorry, minus, it should minus 1 by r into u theta. U theta is what? U theta is this one, dou u by dou theta. That is r power n minus n into sin n theta. Clear? So now we have to check both are same. So if we notice here, this is n r power n minus 1 cos n theta is equal to this 1 by r into r power n can be written as r power n minus 1. Clear? Into n into cos n theta. So which means that here both the left hand side as well as right hand side both are same. So first equation satisfied. Again second equation is what? N r power n minus 1 sin n theta is equal to minus into minus plus, again 1 by r into r power n can be written as r power n minus 1 into n into sin n theta. Again here left hand side as well as the right hand side both are same. So the second equation also getting satisfied. So since both the Cauchy Riemann equations are satisfied, we can conclude that what is that f of z here? Z bar n, okay, is an analytic function. So whether we are using Cartesian form or polar form, the function should satisfy the Cauchy Riemann equation to test the analyticity.